Anybody confident enough to share their answer? And if you are, try and use that little annotate feature. Tap on your iPad and grab the little pen and tell me how much work was done on that curling stone. See if anybody figured it out. Anna, you got a question?
Oh no, I didn't know.
Oh, you're gonna answer. Oh, okay, yeah, you can answer verbally too. Okay, so raise your hand either, or actually just raise your video hand if you got 152 joules. All right, quite a few. Good. Okay, so in that case, I don't feel like I need to necessarily show you how to do this because you eventually figured it out. Let's just talk about let's talk about the process you went through. So, Kyra, I know I talked to your group. What was the what did you ultimately figure out you had to do to get to this? Like, give me an equation that you used.
We use force equals distance times acceleration.
Okay. Say that one more time.
Force equals distance times acceleration, or displacement times acceleration. Is that what we did?
That?
Maybe. No. Force equals mass times acceleration.
Good. All right. So everybody eventually use F equals ma in this problem at some point. Yeah, you kind of have to because I'm really struggling here. Because this work equation requires a force, and they didn't give us a force. They told us the displacement was 10 meters. And we can talk about it more if you want, but I think everybody figured out it was probably cosine 0 because he's pushing it in the same direction as the displacement. But we need this force value, and the only way to get that is to calculate it. So you go to F equals ma, you got the mass, but they didn't give us an acceleration. So what did you do there? Somebody else help us out. What other equation did you have to bring into the mix in order to figure this out? Grace Clark, go ahead.
So then we knew what our velocity was, and we knew what our distance was. So we did the VI, VF, AX. So
okay.
So we used the equation VF squared equals VI squared plus 2AX.
And you solve that for what variable?
A.
Yeah, and so if you solve that for A, you get like 0.8 meters per second squared. And so you need, good. So you need to get the acceleration from the kinematics so that you can plug that into your force equation from Newton's laws so that you can get a force, net force of 15.2 newtons. Tell me if that's, you got something different. So that you could plug that force into your work equation. So we had to incorporate three different units, three different topic areas that we've done in this class to get to 15.2 newtons of force times 10 meters of displacement times a +1 because the force and the displacement are in the same direction, all to get that 152 joules. All right, that was the crash course, the quick way through it because a lot of groups figured that out. Does anybody have any questions about that process? So 3 equations so that we could substitute a couple times. Wouldn't it be better? Wouldn't it be nice if there was an easier way? Yeah, do you suppose there is? And I'm just messing with you? Of course, because even when we're doing this remotely, I still like to mess with you guys. All right, so I want you to consider this.